Hi everyone, welcome to new session on signal processing. This is the second session. Okay. Now we are going to see about analog signal and digital signal. Okay. In last session we have seen what is signal. Now what is analog signal and what is digital signal. So this is the representation of the analog signal and this is the representation of the digital signal. Usually digital signals are represented using zeros and ones. Okay. So these analog signals are used in the previous versions of computers, like you have seen first generation, second generation. Okay, in those computers we have used only analog signals for processing. Now what you are using are digital signals. So they process the data in the forms of zeros and ones. Okay, analog signals are represented with the sinusoidal curves, whereas digital signals are represented with the square waves. Okay, now analysis of analog signals. Okay, analysis of analog signal is difficult because whole signal is taken for analysis, whereas analysis of digital signal is very much easier. Okay, I'll tell you why. This analog signal is difficult and this digital signal is easier. Okay, this representation, as I said, it is represented with the sine waves and this is represented with the square waves. Okay, and then storage of analog signal needs infinite memory, whereas digital signals need very small amount of memory. Why? Because those days analog signals are recorded as like they are generated. If they are generated in this form, like from here to here or whatever the memory, they are stored as such. Whereas digital signals are sampled, quantized, and then they are processed, then they are stored. Okay. So this need infinite memory space, whereas this need only small amount of memory space. Okay, this subject to noise. In those days, they used copper kind of things for transmitting these signals. Okay, so those tends to catch more number of noises. So this tends to subject to noise more. Analog signals, whereas digital signals nowadays we are using modulation techniques. So this reduces the errors. Noise rate very less, so less noise. Okay, now recording techniques. As I said earlier, recording technique is like a full waveform is used for recording the analog signal. In digital signal, only the sample and quantization. What is meant by sampling and quantization, I'll tell you later. Okay, in the later session. So here whole signal as it is recorded, as it is generated is stored, and here only the sample at sample and quantized signals are stored. Okay, so data transmission and memory power bandwidth. So let me tell you what is memory power about first. Okay, so it needs large amount of memory as it is stored. Okay, as it is stored as it is. So large memory, and for storing this large memory and complete data processing, it needs more amount of power. Okay, as we are storing the data as it is generated, it needs large amount of memory and also it needs more amount of power. Whereas here it needs less memory and less power. The only one advantage in digital signal is the bandwidth required is very less. Here the bandwidth required is more. Okay. This technical term like bandwidth, memory, power, I'll be explaining day by day when the session go off. Okay. So now I have left this data transmission, right? So data transmission, so here the data transmission in those days they have done using the copper channels, copper wires. Here now we have so much of optical cables and we are now also transmitting using wireless also. Okay. So data transmission is difficult in analog signal because it captures more number of noises. Here data transmission is more easy because we have only storing the instantaneous values. Okay, I mean only quantized and sampled values. Okay, this analog signal is also called as continuous signal, and this digital signal is also called as discrete signal. Okay, so this is about analog signal and digital signal. Let me teach you different types of analog signal and digital signal, how to make analog signal to digital signal in the next session. Until then, see you later. Bye bye.